want to get we want to answer this question. So let's read this question. Let's see what we have here. So we're given this information. We're given this table. I made this graph relative to this table. So I just plotted these points on this graph for each one of these points. So 0, 10, right? See, and then 2, 14, right here, and so forth and so forth. And I just did an approximation for where these points roughly all are. Now let's read what it says. So g of x is a continuous function from 0 to 25, where g of x is the rate that Catherine travels from her home to school in meters per minute. X is in minutes. Find the distance that Catherine travels. Find the distance using a left Riemann sum. Now we need to use a left Riemann sum, and what we're doing is we want to approximate the area underneath this curve, where there's going to be some curve that connects all these points, because g of x is a continuous function, and it gives us specific values for that function, and you want to use left endpoints, left Riemann sum. You're using left endpoints. So the curve as a whole could look like a variety of things, right? You don't know what it looks like, but the curve connecting these points could be, it has to be whatever curve it looks like, it has to connect those points continuously. So you want to approximate the area using a left Riemann sum. The first one is going to look like this. And the thing here is that each of these widths now is no longer equal. So I'm going to draw what this looks like in the graph. So now it's no longer equal because look, it goes, this width is 2, and then this width is now 3 for this one here. And you want to use it for each one of these things like this. So now it's no longer equal. This is going to be from, so that was 5. What's the next one? Oh wait, not 5, it's 6, sorry. So it's to 6, so let's make this a little bit clearer. So I made it 5. I just put that point there to start originally, so it should be to 6. So it should go down to 6. And then the next one, let's just draw the rectangles so I don't make a mistake. Right, to 8 is the next one. And then the next one is going to be from 8 to 15, so 15 is all the way over here. And then the next one is to 20, so that's over here. And then the last one is from 20 to 25. And you should see that each of these widths are now no longer equal length, not all of them at least. So this width is 2, this width is 4, this width is 2, this width is 7, and then this width is 5, and this width is 5. And now you need to compute the heights. So what's the height? The height is going to be the x value for each one of those points. So if you wanted to find the sum, right, again, it would be left endpoint. So let's see, we start off with this height. It's going to be 10. So the area of this rectangle is going to be 20, and I'm just going to put in the areas. So this area is 20. Why is it 20? Well, its height is 10, and its width is 2. Then what's the area of this one? Well, it's 4 times 15, which is 60. And then this one's 2 times 20, so it's 40. And then this one is 8 to 15 is 7, so it's 7 times 15, which is what? 7 times 15 is going to be 7 times 15, 70 plus 35, 105. And then you're going to have, this is 5 times the 30. Let's see, what's f of 15? This is 15 here. That's the left endpoint. So 15, the height is 30. So 5 times 30 is going to be 150. And then this is 5 times 20, because it's the 20. 5 times 20 is 100. And if you want the approximation using left Riemann sums, you just add up all these values. So it's going to be 80, 120. 120 plus that is 225 plus 150 plus 100 is going to be 250 plus that is 475 is about how many meters she traveled. It's an approximation of how many meters she traveled. And that relates the idea of that the area underneath this curve, right, if whatever the curve looks like, is the distance that she went, right?